Okay, so this is 7.5. We're solving for theta, only it's a little bit more tricky than 7.4, but it's the same-ish idea. So you need to have out your unit circle, and then eventually we might need some identities, formulas, but we'll try it without it first. Okay, so this first one says sine 2 theta equals square root of 3 over 2. So first, we're going to throw a sine inverse on both sides. And it makes it cancel on the left. So you have 2 theta equals sine inverse of square root of 3 over 2. And this problem said solve the equation on the interval 0 to 2 pi. So I need all the answers in between 0 to 2 pi. So first, let's figure out what sine inverse of square root of 3 over 2 is. Sine is the y value. So I'm going to look on the unit circle for when y is square root of 3 over 2. It's pi over 3 and 2 pi over 3. So we're going to say 2 theta equals, what did I just say? Pi over 3. And I left a little spot there. 2 pi over 3. And remember that thing from 7.4 where you have to put plus the period in? And the period of a sine is 2 pi over b, or just 2 pi n plus 2 pi n. Okay. Now, this is true for just theta. Like theta equals sine inverse square root of 3 over 2. But we have, boom, 2 theta. So to solve for this theta, we're going to divide by 2. Everywhere. Panic at the disco. So you get theta equals pi over 3 divided by 2. I don't know. Let's see. Pi over 3 divided by 2. That's like saying pi over 3. Keep, change, flip. So keep the pi over 3, change the divide to a multiply, flip that 2 over 1 to 1 over 2, and that makes pi over 6. Okay, so pi over 3 divided by pi over 3 divided by 2 was pi over 6. Okay, and what's 2 pi n divided by 2? The 2's cancel. So you get plus pi n. Okay, then over here when we divide by 2, you say keep 2 pi over 3. Change the division to a multiply. Flip the 2 upside down to 1 over 2. Cancel the 2's, and it just gives you 1 pi over 3, or pi over 3. So we have theta equals pi over 6 plus pi n, and pi over 3 plus, let's see, 2 pi n divided by 2 is just pi n. And you're probably wondering, why the heck did I divide by 2 again? Well, in 7.4, we started out with problems that said sine theta. If I would have had sine theta, then yeah, my answer would have been this pi over 3, maybe this 2 pi over 3, yeah. But we have 2 theta, so that means we have to divide everything by 2. And we get pi over 6 plus pi n and pi over 3 plus pi n. Okay, so we're going to come up with all the answers that match this information from 0 to 2 pi. So let's think about this. My first answer is definitely going to be pi over 6. Because if you plug in 0 for this n, or if you try and add 0 pi, you just get pi over 6 plus 0, and that's just pi over 6. Okay, let's try plugging in a 1 to this n. That's pi over 6 plus 1 pi. 1 pi is 180 degrees, so let's look at our circle. Here's pi over 6. And we're going to add 1 pi, 180 degrees. And we end up at 7 pi over 6. Okay. Now, if I plug in 2 for this n and say pi over 6 plus 2 pi, well, that'd be bigger than 0 to 2 pi because, hello, it's pi over 6 plus 2 pi. So these are the only two answers I get from this first little pi over 6 plus pi n. Now let's go over to this. Pi over 3 plus pi n. If I plug in a 0 for n, I have pi over 3 plus 0 pi. Pi over 3 plus 0 pi is just pi over 3. Okay, so we have pi over 3. Now let's plug in a 1 for this n. Pi over 3 plus 1 pi. Well, let's go looking for it. Here's pi over 3. And if I add 1 pi, or 180 degrees, pi over 3 lands on 4 pi over 3. So if I add 1 pi, I get 4 pi over 3. What about if you add 2 pi to pi over 3? Pi over 3 plus 2 pi. That'd be too big because we're supposed to be in the interval 0 to 2 pi. So this problem has 4 answers. Pi over 6, 7 pi over 6. Pi over 3, 4 pi over 3. Weird. Let's do another one. Let's say cosine 4 theta equals square root of 2 over 2. Well, first you put a cosine inverse on it, and you get 4 theta equals cosine inverse square root of 2 over 2. Okay? Then we take care of the cosine inverse square root of 2 over 2. So cosine is x, so we look for when x on the unit circle is square root of 2 over 2. Here it is, pi over 4, and there's one below at 7 pi over 4. So we have 4 theta equals, what did I say? Pi over 4 and 7 pi over 4. That's where x is square root of 2 over 2. Then you have to add the period, and the period for cosine, sine, secant, cosecant is 2 pi n plus 2 pi n. Okay? So you think the answers are going to be like 7 pi over 4 and pi over 4. Well, let's see it. Trickery dickory. Let's divide by 4. And it cancels out on this 4 theta. So you get theta equals, pi over 4 divided by 4. That's like, keep pi over 4. Change the divide to times. Flip the 4 over 1 to 1 over 4. Holy poop, that makes pi over 16. What the heck? Let me skip down here. So theta is equal to pi over 16 plus, let's see, 2 pi n over 4. That reduces to just pi n over 2. It's true. Okay, now let's work on this other piece. I have to divide him by 4. So I do keep, change, flip. So keep 7 pi over 4. Change division bar. Flip this green 4 to 1 over 4. And you get 7 pi over 16 plus, let's see here, this 2 on the 2 pi n and the 4 reduced to just pi over 2 n. Okay, so we have to figure out all the answers that satisfy this in between 0 and 2 pi. This problem was still in between 0 and 2 pi. So let's see here. Maybe I need to figure out what the heck 2 pi is as a denominator of 16. So I need to be in between 0 and 2 pi, but I don't know what the heck that is with a denominator of 16. Well, 2 pi has a denominator of 1. And if I want a denominator of 16, I have to multiply by 16 over 16. And that makes 32 pi over 16. So this is going to help us. Instead of saying we need to lie in between 0 and 2 pi, we can say we have to be in between 0 and 32 pi over 16. So that's going to help us when we start finding our answers. If we have something bigger than 32 pi over 16, then it's too big and it's not in this interval and we need to cross it out. So let's start doing this. Pi over 6 plus pi over 2n. It's not as easy as the one before, because the one before we were just adding pi in 180. This one we have to add pi over 2. So first let's kind of do what we did on the interval. Let's change this pi over 2 to a common denominator. That means I have to multiply by 8 over 8 to get a 16. So this is like saying pi over 16 plus 8 pi over 16n. Okay, and this is 1 pi over 16. Okay, so what we're going to do is we're going to add multiples of 8. Like, if I plug in a 0 for n, this whole second chunk squashes out, and I just have 1 pi over 16. Okay, what if I plug in a 1 for this n? I have pi over 16 plus 1 times this is just 8 pi over 16. So 1 plus 8 is 9 pi over 16. And that's still within this range of 0 to 32 pi over 16. Okay, I could still keep plugging in numbers for the letter n, or I could just add multiples of 8. So let's see here. 9 plus 8 is 17 pi over 16. And it's still within that 32 pi over 16 range. Let's add another 8. 17 pi over 16. 17 plus 8 is 25 pi over 16. Still within that range of 32 pi over 16. Okay, let's add another 8. 25 plus 8 is 33 pi over 16. And boo! That's too big because we're not supposed to go over 2 pi or 32 pi over 16. So let me cross that baby out. So these are the 4 that match for this first sucker. Pi over 16 plus pi over 2n. Let's work on this one. 7 pi over 16 plus pi over 2n. Okay, first I need a common denominator. I think I'll do it in a different color. So the common denominator is 16. So I need to multiply by 8 over 8. And this sucker turns to 7 pi over 16 plus 8 times pi. 8 pi over 16n. Okay, so let's see here. If I plug in a 0 for n, I have 7 pi over 16 plus this times 0. Well, that just cancels. So you just have 7 pi over 16. Okay, now if I plug in a 1 for n, it's like I'm adding 7 pi plus 8 pi. So that makes 15 pi over 16. And that's still okay because I'm within that 0 to 2 pi or 0 to 32 pi over 16 range. Okay, so instead of plugging in the numbers for this n over and over, let's just add multiples of 8. So 7 plus 8 is 15. 15 plus 8 is 23 pi over 16. 23 plus 8 is 31 pi over 16. 31 plus 8 is 39 pi over 16. But 39 is too big because we have to stay in between 0 and 32 pi over 16. So boom, that one's out. So for this question, it was cosine 4 theta equals square root of 2 over 2. Well, there's a bunch of thetas that I could plug in that when I multiply it by 4 and take the cosine, I get square root of 2 over 2. And those thetas are pi over 16, 9 pi over 16, 17 pi over 16, 25 pi over 16, 7 pi over 15 pi over 23, 31. All those. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 answers. Ah!